Friends, today we are going to discuss one important topic in module 3 is properties of Fourier series. This is the last topic in this module. Fourier series, properties of Fourier series. The first property is linearity. So now I am going to apply the linearity property for the Fourier series. Before going to apply the linearity property to the Fourier series, what is linearity property? What it says? Linearity property states that it should satisfy the superposition theorem. What it says? Weighted sum of the input gives the weighted sum of the output. So for that we need weighted sum of the two input signals. So our discrete time Fourier series, continuous time Fourier series x of t, that is one input signal x of t continuous time Fourier series. Fourier continuous time signal x of t. If you apply the Fourier series to x of t, we'll get x of t. Same thing y of t. Y of t is one more continuous time signal. What is the continuous time signal y of t Fourier series is y of k. Now if you apply the weighted sum of these two input signal a into x of t plus b into y of t is supposed to get weighted sum of their Fourier series. So that is nothing but a into x of t Fourier series is x of k plus b into y of t Fourier series is y of k. So here I am assuming as a weighted sum of the input is, that is the continuous time z of t, weighted sum of the outputs, that is the Fourier series of z of t is z of k. Now we are going to prove it. How to prove it? Now I am going to consider our RHS is z of k. Z of k is nothing but a Fourier series expression of the z of t, continuous time signal z of t. What is the formula? Z of k is equal to 1 by t integration that input signal z of t into e power minus j k omega naught t dt. What is z of t? What is z of t? What we assume? Z of t is nothing but a sum of these two input, weighted sum of, that is a into x of t plus b into y of t of that e power is common. Now we can divide this expression into two. One is a into, a is the constant, we can take it out, a into 1 by t integration x of t e power minus j k omega naught t dt plus one more is b is constant in the second expression, can take it out, b into 1 by t integration y of t e power minus j k omega naught t dt. So if you observe that the Fourier series expression and if you apply to these two expressions, we can conclude that the first one a into the first expression gives this is Fourier series of x of t. Similarly b into second expression gives Fourier series of y of t. Then directly we can write it as a into x of k. Fourier series of x of t is x of k plus b into Fourier series of y of t is y of k. That is only z of k. That is only we want to prove it. We proved. Clear? What linearity property states? It states that weighted sum of the input, weighted the sum of the input gives the weighted sum of the output. So that is nothing but a weighted sum of the two continuous time signal should give the weighted sum of the their Fourier series expressions. Clear? Now second property. What is the second property? Time shift or translation. Time shift. Time shift is nothing but let us consider x of t is our continuous time system. Continuous time system. What is the Fourier series of x of t is x of k. Then I want to apply the time shifting property. Time shifting property is nothing but x of input is shifted. X of t is our original continuous time signal. Time is shifting. I'm here in this case I am going to consider time is shifting right hand side. So t minus, we can consider t minus t naught or t plus t naught. So t minus t naught is equal to z of k. Normally you know that is nothing but x of k. X of t is Fourier series is x of k. We are shifting minus t shifted to t naught. So for that we have to get the x by e power minus jk omega naught. Instead of t will get it as a t naught. Here we are shifting the right hand side t minus. If you same thing, if you applied x of t plus t naught means e power instead of minus will get it as a plus. So now I am going to prove this one, z of t. How will get z of k? That e power minus j into shifted into x of k. how we are going to prove it. Let us prove it. Okay. Now what we have to prove? We are going to consider what is our x of k. X of k is equal to 1 by t integration x of t minus t naught x of t. X of k is equal to 1 by t integration x of t into general formula. You know, correct na? That is the Fourier series expression for the given continuous time signal z of t. So z of t into e power minus j k omega naught t dt. What is x of t? Z of t we assumed x of input, time shifting of the input signal x of t, that is x of t minus t naught. Now for simplification purpose, we can consider t minus t naught is nothing but a m. I am going to consider t minus t naught is equal to m means what is t? T is equal to m plus t naught. I am going to substitute this in the above equation. We'll get it as a z of k is equal to 1 by t integration. This is x of t minus t naught. T minus t naught, what we assumed? Yes, correct. X of m e power minus j k omega naught. What is t? T is nothing but m plus t naught into dt. Now we can divide this e power expressions into two. One will be e power minus j k omega naught m e power minus j k omega naught t naught. Omega naught t naught. Correct na? E power minus. So now if you we are doing the integration with respect to t, so 1 v power minus j k omega naught t naught is not in terms of t. We can take it out from the integration, and remaining expression is integration e power minus j k omega naught t naught integration x of m e power minus j k omega naught m into dt. So if you see the second one, it is in the form of Fourier series expression. Directly we can write it as it is the Fourier series of, what is the signal? Continuous time signal x of n. So what, that is only we want to show now. That is all. So x of t minus t naught, time shifting x of t minus t naught is equal to e power minus j k omega naught, what we shifted. So we shifted minus t naught means we are equal to minus t naught into x of t Fourier series is x of k. Similarly, if you are, whenever you are going to consider left hand side, that is x of t plus t naught means t plus t naught Fourier series is e power, here plus means e power, here also e power plus j into k omega naught t naught x of k. Good, clear the Fourier time shifting property. And next one more property here, same thing, x of k is nothing but e power minus j k omega naught t naught into x of k. Now frequency shifting, the previously we shifted as a time shifting. So time shifting is nothing but input side x of t, continuous time signal is shifted. Now whenever you are going to do the frequency shifting is nothing but I'm going to consider as a, let us consider x of t is the continuous time signal, that Fourier series is x of k. Now we are going to shift, that is nothing but a frequency is nothing but a t is shifted, t is converted to x of k. So here k is nothing but a frequency, t is nothing but a time. The previous property time shifting, so x of t shifted to t minus t naught or t plus t naught. Now our right hand side x of z of k should be shifted to x of, otherwise x of k will be shifted to x of k minus k naught or k plus t naught. So e power expression should come in the left hand side. What should come? E power j into here k minus k naught. If we shifted right hand side means here opposite. Variously minus means minus, plus means plus. Here minus means here plus will come. E power minus j k naught omega naught t into x of t. That Fourier series is x of k into, sorry, x of shifting x of k. Here plus means here minus k naught. Clear? Now let us prove this one also. Let us consider, we are going to prove z of k. Z of k is equal to, what is that? 1 by t integration. We know the formula for Fourier series now. Z of t into e power minus j k omega naught t dt. Okay. Now what is our z of t? Z of t is nothing but e power j k naught omega naught t x of t. I am going to substitute. Then I am going to combine both e power. If you combine both e power, what will come? Power minus j into k minus k naught omega naught t dt. Okay. Now if you write in terms e power minus j into, instead of k, what is there? K minus k naught omega naught. If you compare this expression with our original Fourier series expression, instead of k we have k minus k naught. Then we can write it, this is the x of k minus k naught. So now x of k minus k naught, if the reverse process, if you do means e power minus j k naught omega naught t x of t Fourier series is x of, here plus means minus x of k minus k naught. Same thing, e power minus j k naught omega naught t x of t Fourier series is x of, here minus k naught means x of k plus k naught. Clear? This is frequency shifting. The previously is the time shifting and linearity property. These are the three important properties in a Fourier series. Okay, clear? Thank you.